What about ye? This one here, this is a part 2 of a series. This is my own Jeep, a Toyota Hilux Surf. It's got the 3-litre KZN 130 engine in it, and the problem is we are having transmission issues with shifting very late and not going into overdrive. Okay, this is part 2 of the series. If you have this issue and you're wanting to know a wee bit more, you're probably better watching the whole series whenever they all come out. There'll be a part 3 after this one, and there's a part 1 already posted. Links in the doobly-doo, and away we go. So, anyway, what we're having with this car is it is very late at shifting, so it revs about 2,000 revs from the change from first to second, and then in the third, and doesn't go any higher than third. So it means that you're revving the head off the engine, and you're not going very fast. So we'll have this troubleshooter thing here, but this is for an A340H automatic transmission. And the one in this car is an A343F. So I expect slight discrepancies, but essentially it should be very similar. And we saw this here before: delayed 1 to 2, 2 to 3, 3 to overdrive, and all that there. And it comes off with ECU valve body or solenoid, and just to inspect all those. So there's a lot of things in here. You know, it talks about the fluid for certain issues. Clearly the fluid is one of the first things you want to look at with your automatic transmission or automatic gearbox. Here we go for manual linkage out of adjustment. So there's mechanical things that need to be correct depending on the problem that you're having. But what I did notice in this wee troubleshooter thing is, you know, a lot of things you have here, it's ECU valve body or solenoid valve, or just the complete gearbox here, disassemble and inspect transmission. So there's valve body, solenoid valve, ECU again, ECU, solenoid valve, and it seems to be quite prevalent in that. So it goes on to do a quick diagnostic, which we're going to do, and I'm going to show in this video a few quick, simple, basic checks. You don't need any tools, and it may give you a wee bit of a head start. So, as with any diagnosis, you know, it's so easy to forget about the basics and, you know, get embroiled in that document there and, you know, start testing things and doing all that. The basics in any sort of automatic transmission type issue, first thing you look at is the fluid. And in these cars, dipstick's just looking at you there, that red thing there, that red cap, and just pull her out. Now, the proper way to look and to check the level of the fluid is with the transmission fully up to temperature, about 80 degrees Celsius, and with the engine running. Take the dipstick out, give it a wind, put it back in again, you'll get a proper level. But all I'm going to do here, this engine here is stone cold, and so I'm just going to pull the dipstick out. It gives me an idea of the level, basically to see if there's any oil in it at all. And most importantly, the dipstick gives us a sample of the oil, so it's able to tell us the condition of the oil, because, you know, you're taking a sample. So we'll pull this dipstick out here. Okay, here we go, and we'll see what we'll have. See if we can get that into focus for you. Okay, so looking at the dipstick, it's wet. So we'll have 2 markings on these, and that's a cold hand low and a hot hand low. As you can see here, it's up here at the hot. So to get a proper accurate reading, the engine needs to be warm. So I've already done this with the engine warm, and the level is good. And I have the dipstick holding upside down in it, so it's actually rolling down it. But this gives you an idea of the level. But as I said, the most important thing is to get a sample of it. So if this is brown in colour, if this oil is starting to go brown or nearly black, you need to change it. So if we get a wee sample there, we can see it's still reddish, which is the colour of the fluid whenever it comes out of the bottle. Now, I know this is my own Jeep, so I know that this is going to be good because I did a drain and fill in this car at the same time that I changed that oil filter, which is March 2020, so it's about 4 or 5 months ago. I keep the ATF in good condition in this car because it's my own vehicle, and there's no excuse not to do it. So every couple of years I would do a drain and fill, so which means you just take the bung out and you let whatever comes out drops out of it. So it's a dump basically. You just dump whatever oil is in the pan out of it. You can measure it if you wish, whatever came out, and put that quantity in fresh fluid back in. Now you need to set up a hose type idea, and I have a hose with a wee connection on it and a funnel, and I get it in place here at this position. It takes a good while. You have to be patient for to get that 4.5 litres is what usually comes out of it back into it again. But if you've got transmission problems, this is a first check, and it takes 2 seconds to do that. So our next wee quick and simple test, which may tell you something, may not, but it's dead easy to do, and again, no special tools, just a wee bit of knowledge. So there is a built-in diagnostic system into the transmission control unit, which is part of the ECU, and we have our overdrive light. That light gives us a series of flashes, and that corresponds to codes, So I'll just do that quickly. I'm not expecting to get any results out of this, but I'm just going to run through some of these tests for everybody else, So big one is that the overdrive switch must be in the on position. So there's a hint here: warning and DCC can be read only when the overdrive main switch is on. So whenever you have the switch on the gear selector in the on position, there's no light on the dash. The overdrive light isn't on. Whenever you switch the overdrive off, that light is permanently on. So if that light is permanently on, if you have selected that for that light to be permanently on, then this isn't going to flash for you. So it's just going to be on the whole time. So with that wee quick bit out of the way, there's a wee diagnostic socket in the engine bay, and this SST special service tool is basically a jumper wire, and people use paper clips and whatever else you have, but we'll have a wee look at that, and we'll do this wee quick test. So in the left side of the engine bay, this is the air intake, the air filter here. We'll have this wee bio here, diagnosis socket there. I don't know of anything that plugs into this. You maybe get something, but you have a terminal there, a terminal there, but you have a wee legend here, so that wee mimic panel there mimics that. So it's not a mirror image, so you can tell there that you have this one here, and then is that one there, so your orientation. So what we want to do here to get a quick diagnosis, is we short out E1, which is that one, and TE1, so that's for the transmission, and TE1, and E1. So these always have a lot of grease in them, so you might want to sort of hook out a wee bit of grease there. And there's a lot of guys probably do this with a paper clip or something like that, but our special service tool in this case is going to be a jumper wire and a couple of back probes. So what we're going to do is just make sure we'll have a connection and get her nicely in there. There we go. and E1 there. So we'll just show you that. So that's TE1 and E1 connected together, shorted out. Simple as that. So those two terminals jumped in the diagnostic port, then we simply turn the ignition on, and there's what we get. So you can see the engine, the check engine light flashing, and the overdrive there is flashing. That is normal. What we're seeing there is no faults at all. So if there are faults, this will, it'll give a pause, and then there'll be a gap, and you count the flashes in, and then it'll go off for 2 seconds or something like that. This flashing sort of, I think it's twice a second it flashes, and that is normal. Find out where service information, so there's it connecting with the special service tool. It does say here about measuring voltage and ohm. Yeah, okay. This will only really show you anything if it has an electrical problem. So it's good if you have, say, a broken wire to a solenoid or something like that. This might tell you, that might tell you, it might lead you into that path. So my light in this case is normal, and that is your normal frequency there. So if the system is operating normally, the light will flash 2 times per second. So that is normal. And you read the code if there is one. The easiest way, if you do have a code and you want to start again, of erasing the code, is just disconnect the battery and reconnect it again. So just take power off. There is another way of doing it. You can short another couple of pins out, and it will actually erase, but just disconnect the battery. It's the easiest way. So here's, if you do get a code, that's normal. The flash in there 2 times per second, and then a 4 and then a 2. So it'll flash 4 times, and then there's a pause, and then it'll flash twice. 4-2, 6-1, 6-2, 6-3, 6-3, and 6-5 are all transmission codes, and they're all relating to, well, there's a vehicle speed sensor circuit 1 and 2, solenoid short to ground or severed wiring harness, short to ground solenoid number 2, severed lockup solenoid. If you have a lockup in your torque converter, some cars don't have that. Severed number 4 solenoid. So again, it's really electrical that this will show up. Clearly, if you have hydraulic issues or something like that, that test isn't going to tell you. It's not the be and end all. It's good, quick test. Check the oil and do that quick test. Doesn't cost you nothing. 5 minutes does it, and it could tell you something. In my case, both are fine, and that's not giving us anything. So there's a wee sub note here. If codes 62, 63, 64, 65 appear, there's an electrical malfunction in the solenoid. So causes due to mechanical failure, such as a stuck valve, will not appear. So it's, again, not the be on the end all, but it's worth doing. And there's a wee thing there, how to cancel out trouble code, but you can just disconnect the battery. It does the same thing. Okay, we're not going to go through this whole document, but I'm just going to point out some of the things that I've already spoken about. As we move on in the document, it then suggests to check the fluid. So there's it there, fluid temperature 70 to 80 degrees centigrade, and check it when hot. So I've already said. Moving on, if you watched the first video, I did mention in that I have actually been driving this Jeep in manual mode. So this is where it says that, and this is a test to see, whether your gearbox Donald ducked or not. So this is a brilliant test. It's dead easy, and 2 seconds does it. All these tests are like, you can do this in 10 minutes, and you'll have pretty good direction. I'm going to show you another couple of tests too, as well. But here we are for manual shifting test. So you basically shift the gears manually. So this is to check your mechanical action. So with this test, it can be determined whether the trouble lies within the electrical circuit or there is a mechanical problem within the transmission. So this is probably the best test you can do, nearly. Disconnect solenoid wire, and I'm going to show you that. Inspect manual driving operation. Check that the shift and gear positions correspond with the table below. So here we go. Drive, you get overdrive. Second, you get third. L is first, R reversed, and P is Paul lock. So there we go. If L, 2 and D gear positions are difficult to distinguish, performing the following while driving, shift through the gears there. Check that the gear change corresponds to the position. If any abnormality is found, the problem lies with the transmission itself. And then it says reconnect the solenoid wire and cancel the diagnostic code. I have been driving the Jeep about in this mode. So these tests, I'm going running through these tests over again for the sake of the video. I've already done all this, to be quite honest with you. And that's solenoid functioning there, which I'm not going to go into. And that's an electrical diagram, but I suspect mine may be slightly different from that. This is a graphic of a generation 3, and it's showing a few solenoids there, which are actually inside. The main solenoids are inside the gearbox. There's 3 solenoids, 3 wires goes to the solenoid connector, and we can do a simple electrical check. This is to test the throttle position sensor. This is a good test as well. The car needs to know the position of the throttle, so you can do a voltage check and make sure it's stepping up. You can do that if you wish. I actually did do that and found that to be okay. That can give you shifting issues now. There's no doubt. But what we're going to do now is we're going to do an electrical resistance check on the solenoids. Again, the solenoid moves in and out, and it moves fluid. It's a hydraulic. It creates a hydraulic action. You could have problems with your seals in your solenoid, and it's not able to hold pressure or something like that. So this isn't a definitive test. It's one of those tests where if you find the problem, then there it is. There's a smoking gun, but it doesn't mean to say that the solenoid is still performing the way you need it to. So I have pinouts here, but again, this is for a slightly different version that I have, and I'm gonna show you a dead easy way to get these pinouts to do this quick test here. So we're going to do a resistance check on the solenoids that are inside the gearbox. And in this car, there's 3 solenoids, so we don't want to take the gearbox out and all that. Now you could do it at the multi-plug off the gearbox, but it's very difficult to access. It's quite an awkward position, and this check here will test our wiring as well. Now with no codes in my case here, so I'm not expecting to find anything by doing this, but I'm just showing you this is a quick test that you can do just to rule all that sort of stuff out. And it'll give you an idea of how good your solenoids are. So the ECU is in behind the kick panel. This is the passenger UK front door here, and I just take off a bit of trim at the carpet there first. It makes that plastic thing to come off very easily. There's one plastic nut, 10mm sort of nut there. You can just screw it off your hand usually. And as you can see, I've disconnected this first multi-plug here. I've still got the ECU in place. Now the thing about this ECU is there's 2 boards in this ECU. So the ECU is connected to another board, and both serve both functions, but it's basically the ECU, and the TCU, the transmission control unit, is in that. So that's why, if you notice there, it says AT on it. So if you have a manual, then I think it'll only have 1 board in it. But clearly the 2 AC, a manual and an automatic, are different because there isn't the control for the gearbox in the manual one. So it makes sense, but it's all contained. It's all done in this one box. There's nothing else. So just in case you weren't aware of that or whatever. So I've disconnected this plug here. So I'll get you in that. So a quick look at this plug. Now the reason why I'm disconnecting this first plug, in our guidance document there, it suggested that the solenoids were wired into this plug. But right away I can see that this one is different, because one of the solenoid wires that it talks about isn't populated here. So I don't know how you can see that or not. So on the document, one of the solenoids was here in this position here. So right away I can tell that this is just wired completely differently. So that's why, you know, you have to put, if you're going to replace an ECU or you're looking for an ECU, you have to get the exact same one. Even though a lot of these Toyota ones, they'll have the same pin out. You know, these connectors will fit in. So it says there 26 pin, 16 pin, and 22 pin, and you know there's a lot of them like that. But you know the connections are different. So what I'm going to do is I'm going to manually, with a continuity test, find which pin is for what solenoid. So I'm going to do my wee resistance check. So that is our solenoid connector, and it's disconnected. Just one point to note, before I disconnected that ECU and this connector, I just disconnected the battery, and that's just for safety's sake, so you know you don't accidentally short something out or something like that. So I think it's a wise thing to do, just disconnect, or in this case 2 batteries. So we're perfectly safe. You know, we can't do any damage to anything. And what we'll have is we'll have a front probe into the connector on the green wire, I believe it is. I'll just have to double check that. So there's 3 wires. This is a 3-wire connector, 1 wire per solenoid. So the solenoid gets energized from these wires, and then it's connected to body ground by bolted. You know, the body of it is bolted to the gearbox, the body of the gearbox, which is in turn getting the chassis ground. So it's worthwhile as well checking your chassis ground before you do all this stuff. So that's another wee quick test right at the start, is that measure the saver's voltage drop between the battery negative and the engine. So these solenoids won't work if you have a bad chassis ground as well. The front probe in there, I'm into the side of the terminal. I'm not in the terminal where it clicks in. So you have to watch. You don't want to widen out the terminal. That'll give you problems. So we just have a long wire connected into there, and we're going back up into the passenger footwell again. Okay, so we're set up for a quick, simple continuity test, just to determine this multi-plug. So it's pretty basic stuff, and you know, easy enough done. You just need a long lead. You may notice that I have a blue lead that's in the connector, but it wasn't long enough to reach up into the car here, so I've just connected together. So we're just simply going to do a continuity test with ordinary voltmeter, ordinary DVOM with a buzzer on it. Pretty standard. Now the wire color down at the multi-plug for what I'm front probed into is green, but you know, that doesn't necessarily mean to say it's going to be a green wire here. All you need is, you know, a plug connector in the middle of the loom. So, you know, keep that in mind, that it might not necessarily be color coded at this end to whatever color you're onto. Plus down there at the gearbox there, it's quite difficult to distinguish the colors. But yeah, so the service book said that the solenoids were these ones here. So I'm suspecting it to be in around this sort of area, but you know, you have to keep an open mind when you do these things. So there's a green wire there, and as I said before, because I've already done all this, so I'm just showing it. And if I connect into that green wire there we're getting continuity, and so that couple of ohms there is just the wires and stuff like that. So a bit meaningless, the ohm reading there, but we're just using the buzzer in this case. So we'll just keep that plugged in there. Okay, so we've identified all 3 wires at the TCU there, or the ECU common TCU, and I'm happy enough, so I'm going to remove that, and I'm going to plug her back in again, and That means we're going to do resistance check the solenoid, and it'll also, well, we've already done a continuity test on the wires, so, you know, but they're not under load by any means, but we resistance check might help out here. Right, we have our solenoid plugged in then. We need to disconnect the wire that was going to our probe there, and we'll change that over and get it on a good chassis ground. So in this case, I'm going to use the door slam. Here we go. That's connected to ground. So we're still on buzzer there, but it's still giving us an ohm reading, so I'll just change it over to ohms. There. Get rid of the buzzer. So there we'll have 12.7, 12.6 ohms, which is dead on. The specification is 11 to 15. So what we can do, I've identified all three wires, and I know that it's the green one, the purple one, and the red one. So I'll get into the other one here. See if we have a connection. Let's see what happens. There we go. So you need to make sure you have a good connection if you're doing this. It's just 12.6, and the next solenoid is that purple wire there. So we'll back probe it, and there. Make sure we get a good connection. So I'm sort of just putting a wee bit of pressure on the probe, you know, to hold it against it, and see what we're getting. Oh, we're not getting anything. But no. There we go now. So you need to make sure you're on, of course. It's 12.4, 12.5. So they're all much the same resistance. So 11 to 15 is acceptable. And yeah. So there we go. That's the solenoids that are inside the gearbox. Tested there using the vehicle wiring. Okay, so those are a few quick and easy tests. So that can just eliminate this. Now, we'll have to remember the symptoms with this particular issue here, with this particular car, is that it actually does shift. You know, so the solenoids are working as far as I'm concerned. So it's more of a control issue, whereas it's not shifting at the right time, or, you know, so to me it's more of a control side problem. You know, I'm showing you those tests there. Those are quick, easy, basic, dirty tests, and you know, I was able to do that in 15 minutes, 10 minutes if I wasn't setting up cameras and stuff like that. So that's just to sort of show you if you have issues with, if you have a solenoid, a bad solenoid, generally speaking, you will get a fault code. I didn't get any fault codes, and therefore I did not expect to have bad resistance on any of those solenoids. However, it takes minutes to do, and you know, we're just ruling that out because it now tells me the control is in this box. That's what controls the shifting, and the problem is in here. So, you know, we want to rule out everything before we even think about, you know, condemning an ECU. So that's the reason for those tests. They're quick and easy to do, and you need a bit of wire and a voltmeter to do it. That's it. So we're going to pull this ECU out. So that's our ECU there out of the vehicle. ECU cum TCU, whatever you want to call it. And you know, as I say all the time in a lot of these videos, when you're dealing with these Jap cars, these screws are not Phillips screws. They are Japanese industrial standard. They are what's known as crosshead screws, and you'll find that if you use the right screwdriver, because these here can be, you know, these are quite tight, believe it or not. And if you use an ordinary Phillips screw in these, it's butcher time. But anyway, there you go. If you follow the channel, I say that nearly every time. we're going to do something like this. But okay, we'll just take these screws out, and we'll see what's contained within. So these are dead easy to open up. Obviously, if you have the right screwdriver, they're not siliconed or sealed. So if your Jeep has taken a bath and there's water has got above the level of the bottom of doors, you're going to have problems. So if you're into off-roading in a big way and all that, you just need to keep that in mind. The position of these electronics here, and clearly you can see that even the connectors and stuff, they had no weather seals on them. When I was back probing there, I was able to get directly onto the pin. You can actually see yourself getting the connection, and yeah. So okay, the big reveal. This is the big moment. Is there anything wrong with this ECU, and how will we know? Well, I'm going to tell you something. I already know there's something wrong with this ECU, and I'm going to tell you why before I even open it up. My car, this Generation 2 Toyota, is 25 years old. These ECUs of this sort of generation, this era of Toyotas, 90s, early 2000s, 80s, 90s, and 2000s, these ECUs contain electrolytic capacitors. So it's a normal type capacitor that you would see in a power supply unit of a TV or something like that. And we all know what happens to them. If they get hot or whatever, they bulge up on the top of them. You can see that the capacitor has burst. So the issue with these ECUs and these cars, whenever they get to this sort of age, basically electrolytic capacitors have a lifespan, and the manufacturers say it's about 15 years. So they basically dry out, and then they can start leaking and stuff like that. So this is very, very common for this type of ECU that they have electrolytic capacitors. It's all sort of through-hole components. It's sort of old school, and we're going to have a wee look inside to see if there's anything we can see.